It's Friday. It's homecoming. I'm not moving around. I'm sorry, first hour. The video. It's not that it was a fail like upload. It just screwed up my computer. We lost it forever. Plus, I think it's okay because I think I was a little passive aggressive in that video. And then the Samuelus haters would be like, "See, mom, dad, parent, or guardian. This is the jerk that teaches me." All right, and then I probably could have gotten in trouble with some of the count. But you know what? I'm going to bring them up again. Okay, some of the things that I had. First and fourth hour. Remember we had the line thing coming up here, and then people I try to make adjustments on their work. Does anyone remember this? Raise your hand. And then some people say, "Hey, just do this and do that." And maybe I was a little direct. I'm ugly, and I have a shirt that a student made for me that says, "The sound of my voice makes people physically ill," and that's okay if I rub you the wrong way. But I'm going to be direct. I'm going to rip this like ripping off a Band-Aid, right? And then some people are like, "Well, I do it this way," and I go, "Well, no, you're good." And then you know what? I have a line. Go sit down. Right? Isn't that what I did with various individuals? Right? I'm trying to show you what the structure should look like, especially when we start doing some complicated stuff like today. All right? And you'll get used to it. There's always a little Samuelus getting used to the evil ogre time, when we start off the school year, and some don't handle it very well. But it is what it is. So I think that's what we did first hour. And I'll reference those things as we continue. Okay, and then just as a highlight of, poor seventh hour. I can't wait for the excuses, seventh hour, about not getting ready for the test Wednesday. Now, if I use this video for the next 5 years, this doesn't apply to you. This applies to 2019 right now. Got it? All right, so we are going to have a test Wednesday, and, seventh hour, you better do something about it. All right, did I say good morning? Good morning. Okay, so here we go. Remember that? And I actually, in each example, when I say inverse, you say switch X and Y, right, class? There are people in here, by the way. And then off to the right, the thing that you could have written down is, okay, let me try to get the words in my mind. The graph of a function and its inverse are reflections about the y equals x line. Y equals x line. Okay? And that's what that shows off to the right. And then I'm actually going to cover this very shortly here. Remember this? We're 18s, that notes from yesterday. X squared is a parabola, but over in blue I only have half of a parabola. All right, well, that's because the restrictions of the original carry over to the inverse when we switch domain and range. And therefore, you can see the graphs are perfect, symmetric to the y equals x line. If I literally graph this y equals x squared, then I'd have this part. That doesn't really match with what you took the inverse of. There is no part that exists there, so we just have to understand it. And that's the world of restricting domains in a way, which we're going to talk about again here shortly. All right, and then when I say inverse, you say, I'm not saying anything. All right, when I say inverse, you say, switch X and Y. So the students look so happy, some of them. All right, so then what I did with this graph is I found a couple specific coordinates, and then what do I do with those coordinates? I switched them. And then I wrote this up here, I think, during first hour's video today. We should have known that was an exponential scenario. And then what is the inverse of exponentials? It's right in there. You can see that word in there. Logarithms. And when we go to chapter 3 and we start talking about graphing logarithms, that's how we're going to approach it. We're going to say, here's exponents, and this is how it turns into logarithms. This magical mathematical algorithm called logarithms. It's awesome. It's one of my favorite stuff to teach. My favorite stuff to teach is just all of trigonometry. I wish I could say it. And that's all next semester. Love it. Can't wait. All right, what's this a picture of, everybody? What is that from your book of functions? Square root. Okay, and we should know that. So what we do when we have to take the inverse, I should have put a more I don't have to. Was it in the homework already in the bookwork? Did they ask you to take an inverse of a picture? Good. And I hope it was complicated. All you have to do is find points in the complicated parts that you have, switch X and Y, put them in a new grid, and then the graph should look the same but reflected over the Y equals X line. So obviously so all that pertinent shape should be there. And yeah, that's -3, -2. This looks like 1, 0. And then this is 5, 1. And then switch them. -3, wait, -2, 3. 1, 0 becomes 0, 1. And then 5, 1 becomes 1, 5. And then the only problem I don't like about this is, do you notice my x-axis is a little bit more spaced out than the y? So the graph's a little distorted. All right, but it does look like half of a what? Half of a parabola is what's happening here. Actually, a square root is half of a parabola going right. If I added the negative square root of the same function, then I would get this bottom half. That's actually true. But that's not what you have, and don't start thinking, shouldn't I plus minus? No, no, no. Hey, and by the way, these functions, I got to erase that there. Isn't this function 1 to 1? Yes? So isn't the inverse a Am I just doing that for fun? Is that like I'm a Star Wars? Pew, 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 pew. That's a vertical line test. What does it say the inverse is? It's a function. So if you have a 1-to-1 function, you're allowed, because mathematicians love functions only, you're allowed to take the inverse of it without any problems. Okay, now, is this a Is this a function, first of all? Yes? Is it 1-to-1? No. So mathematicians say you can't take the inverse of that. By the way, I'm standing up like the crane in class. What movie is that, everybody? Karate Kid. So what is this? What is this picture? It's the cosine kid. All right? So the problem with this, with mathematicians, by the way, this is 0, -2, so that it would be -2, 0 here. And I think it'd look like this. I'm not going to worry about scaling. I think this is is this a function? Yes or no? No. You can kind of take this down as I'm blabbering about this, but this is going to be like in February, March, that you're going to hear this again. Since mathematicians are obsessed with functions, what they do is what's called restrict the domain until you have something that's 1-to-1. And I'm actually doing the restrictions that they literally do for cosine. Because do you notice now that if I ignore all those parts of that graph, that this is 1-to-1? Do you see that? And then when I take the inverse of it, I'm probably going to jack this up. It's one way or the other. I don't really want to think about it, but I think it does something like this. I don't know. But that's it. Does that pass the vertical line test? It's a terrible graph, but the answer is yes. Okay, so that's the idea of restricting domains that we're going to talk about later. Blah, 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 blah. Okay, now let's go ahead and take this down. I can't see this. You're highlighting. Oh, I'm so hungry. All right. Couldn't care less today if you're going to pay attention or not. Of course, I will do that if you're falling asleep, though. So it's kind of like a 50-50. Did I scare you? No? All right. What's the first word of this class? College. Algebra trig. So if you don't want to listen today, good luck. All right, here we go. All right, so in green, it's terrible. This is a truth, and you're going to do this because I asked you to. If functions are inverses, then the following is true. Both g of f of x, I reversed it, that's the bottom part. If I go ahead and compose those functions and I get x, and then also do f of g of x and get x, then that's a confirmation that those two are inverses of each other. Not 1, not 0, not anything other than the letter x. If you're dealing with y and x, g of x and x, the classic everything's in terms of x. So notice what the directions say. It says confirm. What does the word confirm mean? Does it mean that they are inverses or not? It means they are. Okay? So I'm going to get some buffoons. That's what I said. How can he talk to students that way? I'm going to get some people that make that fight. Remember the people up at line up here? But I do it this way. Well, guess what? Keep doing it. All right? And then we're going to see where it happens later when I need sensical, structured, step-by-step work in an organized fashion. And we're not going to fight. I'm going to say, okay, you just keep standing your ground, and I'll just keep marking it wrong. All right? And that's really what's going to come down to. It has to, guys. I know what I'm doing. It's your job. Anyone do geometry proofs before? How many people did a geometric proof before? No one's raising their hand. Thanks. All right? You shook your head, but you can't raise. Okay, no? All right. She's tired today. Long week. All right, so geometric proofs, if you remember, and I think more of you have done them, is it says prove that. That means it's true. What you had to do is use logic in the middle, and that was what you were graded on, the logic in the middle. And that's why I was saying what I was saying when you were in line here. Of course, 7th hour has no idea what I'm talking about because I didn't get to see him Wednesday. All right, we had a little thing where students brought up their paper, and I checked it before they could move on, and, blah, 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 blah. So watch this, and this is what I expect. I expect not snaking. I'm not searching for your work. Someone puts, one step over here. Then, you know what, I'm going to go over here for my work, and then I'm going to put the next step over here, and then here's my answer. I'm not doing it. I'm not a, what do you call that, a scavenger hunt. I'm not doing a scavenger hunt for your work. Not doing it. All right, so let's just make sure we understand that. So step one. He told me that I have to confirm by doing this, which is just composition of functions plugging one function into the other. You could probably skip this step and go right to the one after this, but what do I put in for g of x? What do I put in that place? Just to start the ball rolling. Good, they did say, a couple people said it. You change g of x to what it's functionally called. Okay, so I can see you skipping this. And notice how I'm writing it. One, the next step, and then and it's logically done. Wait till we get to trigonometry. We have something that's called trig identities. Math 3 honors, you know what I'm talking about. Okay? That is very much like a geometric proof where you have to do step 1, step 2, step 3, step 4, and if it's not structured, you're gone. I did say good morning, right? Okay, next. What do I do next? Well, I go to f of x. And then wherever there's an x, what do I put in its place? 4x minus 3 plus 3 divided by 4. Where'd the f go? And you're missing the whole point of a composition of functions. I went to f. It's just like, what's f of 2? You don't see f anymore. You plug in 2, 2 plus 3 over 4, right? Okay, so we got to get this down, so those that are still struggling on this. Then do I cancel the 4s right now? Oh, that's a 6 over 5 equals 2 error. I will show that later. What do I do next? I subtract the 3s, right? Or 3 and negative 3 or this. And then I guess we could probably condense that into a one step there. So maybe for you non-work showing people, what can I do? What little can I show? What's the least amount I could show? Maybe those 2 steps could be removed. That's a maximum. Everything else must be shown so it proves. Because without that, just imagine if I removed one more step. You did nothing, right? Nothing was done. Nothing was proven. There was no correlation to what this question is compared to what you were supposed to do as a student. All right? All right. Why you got to be so mean? Is that a song? Why you gotta be so cruel? Rude. That's it. But then you're only halfway done. Now you have to do g of f of. All right, I'm going to lament. I'm going to skip that second step of, okay, g of, well, maybe not. I think in first hour I did. G of, and then what do we put in this? You put f of x name. Sorry. F of x is the name. Its functional value, I guess, or its definition. I don't know what you would call that. Just it's what it's defined by, which is x plus 3 over 4. Then the next thing would be 4. This is where I'm going to lament. Now here we go. This is the common thing. Anyone that's ever had me before knows I say this. I cannot help you. if you don't know what to do next. This is grade school. Now listen to your mentors? No, peers. What happens to the 4s? Or maybe listen to nobody because nobody said a word. What happens to the 4s? 4 times x plus 3 over 4. They cancel. This is 4 over 1. This is grade school multiplication of fractions. It's because you touch that fraction button on your calculator all the time, the calculator rules go out the window. Oh, it makes me so sad. Okay, so minimally, what could we get rid of out of this? Probably just this step. I would need to see everything else. You're either going to do it or you're not. All right, and by the way, what does that mean? It's confirmed. I guess with the checks, you're fine. You don't have to put. You can say confirmed. Yes, they are functions, but you knew they were or not functions, inverses. I'm sorry, and you knew that. Okay, I only have one more example. The problem is someone at my door? No, I'm freaking out, man, or woman, or whatever. Okay. All right. This does look like fun. Sorry for all the pickup on there. I picked this up from another notes I've had back in the day. Oh, this is a bugger. Okay, and this is the one you want to focus on. Okay, so obviously I have these things, and they're saying again, confirm they are inverses. I almost said the wrong thing. Okay, so as you write this down, here we go. F of g of x is what we're going to start off with. All right, and then g of x, you could skip this next step if you know what this means. But I guess for note purposes, I shouldn't skip any steps. 2x plus 3 over x minus 1. So that's what it means. We're going to plug that in for x. And then I'm going to look up at this function. It's already highlighted. Here's f of x. Wherever there's an x, right here and right here, I'm going to put a 2x plus 3 over x minus 1. What? Okay, so the next thing is, is 2x plus 3 over x minus 1 plus a big dogzilla 3 over 2x plus 3 over x minus 1 over a big dogzilla 2. And then what do you got to do next? Simplify. Somebody jumped on it right away first hour. So proud of this. I got her name, got her face, know her, knew what to do next. Anyone know what to do next? I'll pause and wait for fourth hour. Something. All right. Hey, person first hour, you are all by yourself. Congratulations. We're going to multiply. Nobody in fourth hour knew what to do. So I have value. I'm going to multiply both top and bottom by a big x minus 1 over x minus 1. Why am I writing it like that then? Well, I do, through teaching this so many years, know that students don't know what to do next and why I would do this. Anyone know why I would do this, by the way? It's actually going to get rid of all the little fractions. Okay? And we should know this. And I know every time I do this because I know you did this in Math 3. I don't know if we had, I don't think we did this in my class, in the chapter AP thing. I threw it out. Back in the day we did. But we should know that I could take this binomial and distribute it. And then what happens when I take x minus 1 times this first fraction? It's the whole point why we did this. What happens? The x minus 1's what? Cancel. That's why I put this as x minus 1 over 1. Because you should know how to multiply fractions in this class at this point because it's a grade school concept. You take the numerator times the numerator over x minus 1 times 1, the denominator. But before you do that, you cross cancel. Or you cancel. And these definitely cancel. So the next thing right away from this glorious step that I put here, you put a free 2x plus 3. From a denominator, free from a denominator. But then when people do this, this is mistake number 1. They don't hit that. And that's where you gotta, okay, good. I'm gonna write this out in my notes, because when I write it in my notes, I'm actually writing it into my brain, and I'm actually active. Over, then the same thing happens on the bottom. And I am taking it slow because we should actually know this and know how to do this, but I just want to make sure we take it slow. Then get ready for passive-aggressive, mean, ugly Mr. Samuelus coming up. And then this is what I get, and I got it on your quiz, and I forgot I haven't given back those quizzes. That'll be at least either today or next week. How many people did this? By the way, does 6 over 5 equal 2? Does it? Does it? Does it? Now it does. So what's that math in the middle? Good or bad? Horrendous. I will get so many students that did, oh, okay, good. This is easy. Choo-choo. Those cancel. Oh, let's cancel that 3. Let's cancel that x. Let's cancel. And apparently I have 3 over negative 2. All right? And that is absolutely positively the point of me saying 6 over 5 equals 2 errors. You can never take part of a sum in a numerator and just decide to cancel with another part of a sum or a difference, I should add. And how many people still did that? Do you know what percent of the people, I have a fist clenched in my hand right now, did not put plus and minus in front of the 7 on the quiz when they square rooted both sides? Wasn't that the original burn error that I talked about? Burn, burn, burn. How many times are you going to do it until you stop? Right? Wasn't that what I said in class? Could someone give me something, at least shake the heads? All right? It was over 50%. You got to stop the insanity. All right? And stop making the same mistakes over and over again. And this is another one. All right? You can't. So what do you have to do? You have to distribute and simplify. You still can't cancel anything yet. By the way, you distribute I do this on purpose to be annoying because it's annoying when students don't answer my questions. Distribute say it, class. Negative. Thank you. All right. See the teacher I have? 3, negative 3. He makes me do stuff in class. I just like to sit here. And you're halfway there. Oh. Woo. Okay. All right. Why are we halfway there? Because that's half the battle. And I know at this point, I bet you someone's thinking, has it ever been where the first one does equal x and the other one doesn't? I think it could be possible. I don't remember seeing it. The point is moot. You will do this. Okay? And it will be done. Or you're going to get the red pen. All right? That's the relationship we have. And also, just when we do all these things, like even when we was talking about yesterday you had to have your equation solving skills back. You know, switching x and y, then resolve for y. If I can't solve for a 2-step equation, of course we can't do inverses. It's like so many things that we cover and recover and over and over and over again that at some point, if it sinks in, you'll be successful in the class, if you have not been so far. It really takes your effort, though. Hey, now we got to go to the g function. I'll just change colors. And wherever there is an x, I got to put that in its place. All right? So that's what this looks like. And then I'll show you your freedom on this one. 2, a very big 2. And then instead of x, it's x plus 3 over x minus 2. This is how you insert one function into another. Then a big Dogzilla 3 over x plus 3, x minus 2. And then minus 1. Big one. No, you can't just cancel those now. That's ridiculous. I can't even, you're done. I can't even give you, I could probably give you 1 point on this, maybe. But look at how big this question is. This would probably have to be a 6-point question, right? I mean, there's so many things that you got to do algebraically. So it'd probably be a half point. You accomplish the g of f of x, but then you're mathematically, algebraically, we got some issues. All right. I'm not going to even distribute that 2. We could still do what? What are we going to multiply top and bottom by? Now, everyone should know what I'm going to multiply by. What is it? X minus 2. And then I'll reference the question. Actually, first hour, a person asked a kind of a great question. Shouldn't say kind of, because this looks so unique. When I hit this, what happens? Just tell me what happens. This is the whole point why we did this. The x minus 2 is what? Cancel. But then she asked, shouldn't I hit the 2 as well? And hit it twice? And then I answered her question like this. If I had 2x minus 1 and I wanted to distribute a 3, do you take the 3 and hit that and then the 3 and hit that? Do you or don't you? No. And I'm not, that's not a bad, I'm not saying, it's always back to simpler things that more complicated things are, same relationship. Okay? But then we're going to hit that, and hit that, and then I'll move this along faster. So the 2 remains 2 times, and then it's 2 times x plus 3. So I could have distributed, but you know what? A lot of people struggle, where do I hit that 2? And it's only the numerator, because this is 2 over 1. So 2 would only get hit through x plus 3 anyway. And that shows up anyway with what we have left over here. This is the biggest mistake, not hitting this with a x minus 2 as well. That's what happens. And then x plus 3. Then the other big mistake, this is minus 1. So we're going to have to distribute a negative. Then the next biggest mistake, oh, this looks great. I'm going to do this, and I'm going to do this, and then I get negative 5. 2 plus 3 over, is this right? This is a what kind of error again? 6 over 5 equals 2. And as I'm writing this along, variables are just numbers anyway, aren't they? So they are related to 6 over 5 because those are numbers as well. And the point of me saying 6 over 5 equals 2, which is bad math, x's are numbers as well. So that's why it applies what I'm saying. I don't know. I never understand him, that 6 over 5. Why does he always tell me that stuff? I think it's a coinkydink that we got 5 over 5 or 5x over 5 again. And then we just say confirmed. Or yes, they are inverses. Drop it like it's hot. I'm done.